Basically, today want to give you a brief on how the concept of that Spark. Why we as a data engineer, I told like it is a booming technology and all, but we should know right why it is booming and why they are paying that much of salary. And then we will go through that balance certain um, queries which we had yesterday, right? So we will just go through that queries of yesterday and we will close for today. So give me a minute. Let's start. Okay, so the concept of data engineering or big data started in around in early 2000s. So the concept started just because, as we all know, that usage of internet and social media and all those stuff started to boom up in that early 2000, like 2003, 4 kind of time. This started to produce data massively. This massive data was not able to be handled by traditional methods. Traditional methods means all the data was like very structured data, in the sense proper columnar data which will come with column data which is separated with column and rows and all, straightforward data. So suddenly the data dimension changed in the form of images, web pages and all those things started to come in. This caused a big problem. So now the people need to bring with something out of the box to solve this issue. So that was the requirement of big data, and that was where the big data concept was initially thought of. So that's it. Data engineering, we already have discussed about that. So let's go to the next one. So this challenge was because of the growth of driven data routing, internet, social media, digital technologies. You know how many number of Facebook post happens in a day. If you know the exact count, you will understand the requirement of that sufficient technologies to handle those things. So such type of issues, the challenge was to manage and process this massive volume of data for proper analysis, because these data will help the business to make quite a lot of analysis and make money out of that, or valuable decisions out of that. So for this, complete traditional method failed to handle this complex data, so they need a new technology to come up. That's where the introduction of a technology called as Hadoop came in. Have anyone heard about Hadoop previously? Hadoop. Okay, so Hadoop was the first technology which was brought into the market to handle this big complex data. So it was inspired from the Google MapReduce and Google file system. From there, Yahoo built this massive technology which was called as Hadoop. Hadoop means, what it does is very simple and straightforward. So before that, during this era, no, the companies, whatever companies it is, they used to process data in single standalone servers. Like they didn't have the support of cloud. I'll show the architecture and all those stuff in next. So Hadoop, so this problem is the complete process need to be done in one single server, or take it as a one single computer. So if you have 1000, 2000 like for data with rows of 1000 or 2000, it should be easy to process in a one single server or computer. Think of a data which is having 10 million, 20 million lines of data. It won't be easy to process, right? So that's where Hadoop came in with a distributed processing across cluster of computers. Yesterday, you remember, you people have created something called as cluster here. You remember? You just went and created a cluster. You know what cluster is? Cluster is nothing but a collection of computers. This here, as it is a community edition, free edition, we don't get a chance to create like a cluster with multiple clusters. Sorry, computers. Computer means virtual machines. But when you have the proper version of Databricks, no, we will be able to have multiple computers here. That is virtual machines. You will get an additional option of instances where you can select instances and number of instances. That means at the same time, one cluster can have one or more virtual machines. So what exactly is happening here is, during this process of distributed processing means one single cluster, which is collection of more than one computers, maybe one computer will be processing this data, and this 10 million lines of data will be divided into each five of, or for example, you have 10 in this one cluster. You have 10 virtual machines. That means take it simply as computers. A Hadoop will take the data and it will divide the data to this 10 computers and give it to that, so it can process this 10 million data easily. What happened now? Rather than running this complete data in one single computer, in 10 different computers or virtual machines it is running. This made the process of distributed computer processing, and it reduced the effort, and which now the problem of big data was solved for the first time. So what happens here? This is the old method. So old method, one single server. All the company's data from all the end is coming to this complete single server, and it need to process that by its own. And it doesn't have the facility to do that. And at that time, to increase, because all the companies was having a on-premise server for all these cases, to increase the capacity for this processing was quite expensive. That's where this solution came. What happens is, a cluster in a Hadoop means, normally we say as a master and slave architecture. Nothing but there will be the complete cluster will have a kind of a driver node and worker nodes. Master is a driver node that takes all the data, divides it data to each and every subcomputers, that is the slave or drivers. And this acts as a supervisor kind of stuff. It makes sure that all these slaves are doing its task properly. Finally, it takes all the result, combine this result and give it back to the give it back to the user. So rather than running on a single machine here, we had several machines here to run the same data, which reduced that issue. But this was also not 100% successful. That's where we are coming into Spark. But before that, Hadoop was built on a file system called as Hadoop distributed file system, which stores the data in splitted manner across different machines. And parallelly, it also used MapReduce. We already discussed it was a technology from Google to process this data and independently, and later it combine this data and give it back to the machines in a proper manner. But the problem with Hadoop was, when you run something on your computer, if you do some process on hard disk, it will be slower than when you do in your flash memories, right? Similarly, here all the process was done in the disk. So even if it's virtual machine also, it have disk. So in virtual machines, it was been doing on disk. This reduced the processing. Each time the data need to be processed in disk, stored there, retrieved from there, everything stopped the process of making it faster. That another problem with Hadoop was, it will only start one job. Job means once you submit a task, right? Maybe you are processing 10 million lines of data. You are trying to load this data, ingest this data, and you are trying to display this data. This displaying data, it first to load, it will be divided into different tasks, and each task is been given to the your cluster as jobs, and it will wait for one job to complete for another to be accessed. So this also was solving down, so it was also slowing down the process. Another process which was slowing down was need of a faster real time. It is only going to do batch processing. If you have real time data coming in real time, like once you, like for example, you are purchasing something from Amazon. Once you purchase, the data should be going to the Amazon, and they should be processing your payment and all those things. So these are real time data. So these kind of stuff was not able to be processed in a real time manner in the proper channel. So that's where something new again required. That's where Spark came in. And that's what we are going to learn. Spark, the current trending technology, for one of the trending technology in big data. That's where the Databricks also is built completely on. So Spark was found in 2009 by researchers from University of Berkeley. And additional information, they are the owners of this our Databricks service. They first built this Spark, given to Apache to make it open source. People start to use. From there, they build this application called as Databricks on Spark to process that, and it is now one of the market leaders. So these researchers of Berkeley who built Spark was the owners of Databricks itself. And it addressed most of the limitations of Hadoop. It came with something called as resilient distributed data, which help to process the data in memory. In memory, what I say is, rather than doing in your hard disk, it will do the processing in the RAM itself, RAM of the computer, means virtual machine. This made Spark 100 times faster than Hadoop, and it was a game changer. Completely changed the concept of big data itself. If you have previously, if you want to process a data in 1 minute, now it will happen in 1 second, less than 1 second. So this is what something which changed and introduced Spark, and Spark started to catch the complete market. So that's it. So we need to understand some of the advantages of Spark also before going into Databricks. Spark is data processing in RAM, that is the memory, and make it around 100% faster than Hadoop. It supports multiple languages like Python, Java, and Scala, and it even so one of the features major things that we need to know in Spark is like its components are Spark Core, Spark SQL, Spark Streaming, and MLlib. So Spark Core is something which is the primary entry point of a Spark application. Once you create a Spark application, first we create a Spark session from where we will be creating, will be doing all the communications, all the processing for the to the cluster and to the data. Similarly, Spark SQL. It executes all the SQL queries on large data sets. It helps to execute SQL queries on this large data set. And Spark streaming is to collect. We actually told in Hadoop we won't be able to handle this real-time data, but here Spark's advantages, it will be handling Spark real-time data with the help of Spark streaming. And to handle ML, machine learning, it have a library MLlib which helps the processing of large-scale machine learning data in large-scale machine learning applications. Let me go to the next topic. So that's it. We also have discussed what is clusters, because yesterday when we were supposed to start asking everyone to start the cluster, I know some of the people have some kind of doubt what is cluster and all those things. Cluster is nothing but it is a computer itself. Some cases it is collection of computer. Most of the cases when we process huge number of data, we will need multiple computers, virtual computers, which will be processing our whole chunk of data. Now I'll just show you how the Spark architecture is going to work. Simple. This is same thing. I told you there is something called a Spark core. So for the Spark core, we will need to create a Spark context, which creates a Spark application. Initially, we need to create a Spark context. That is the entry point of a Spark application or a program. Once you create this, there is something called as cluster manager. Cluster manager is something which helps the Spark to get resources. Resources means nothing but computers, virtual computers. In virtual computers, there are two types, driver and worker. We discussed here in Hadoop, same thing. It have master and slave. So same thing here, you can consider as driver and worker. Take a supermarket. So you will have a supervisor kind of a person, and you will have other people to be working there. The supervisor will be only monitoring whether the person is keeping the items in the right rack or the person is doing the billing properly. He won't be doing any work other than monitoring these people. And finally, he'll be end of the day, he'll be taking all the inputs from these people and giving back to driver. Is someone you get once a user runs a program, it goes to the driver. Driver divides this data to be processed into different tasks. For example, if you have like in this case, he got a task which he got a collection of tasks. It was 6. 3 given to this worker node. This is a computer itself, and it is given the other 3 to the other computer, other worker node. So these 2 will work on this. Finally, when it is done, it will return this to this driver computer. The driver will collect all this data, combine this data, give meaningful information back to the user. Am I clear, or should I come again? Because this is a very important point in Spark architecture. Whatever interview you go as a fresher, first thing, if you have Spark in your resume, they will ask to explain Spark architecture. And it is very simple. But some people will take some time to understand, but you have any questions, I can clarify, I can come again on this. Any questions? So I just summarize this. The big data was a technology which was required in the early 2000, which when people started to use internet in huge volume and started social media started to get high boom. There, rather than the traditional data, there was quite a lot of data which was coming in, which was complex data, which was not able to be handled by the current traditional methods. There, the introduction of Hadoop comes. Hadoop was able to process the data, but with some limitations, with the limitation of the data being processed in disk and not able to handle streaming data. This demanded another technology which came in 2009, which was introduced by the researchers from University of Berkeley, which handle this data 100 times faster than the Hadoop ecosystem, which was called as Spark, which used to process 100 times faster with the help of, rather than processing the data in hard disk or the disk, it started to process the data in memory or RAM. This have multiple complex it have multiple things to be processed in this architecture. One is major thing is it is its entry point is a Spark context or a Spark core. From there, it have two components, which is major components, which is called as a driver and worker. When a application is submitted by a user, the driver, the Spark context gets the relevant resources, and in that the driver program will communicate with the user and get all the tasks. Whatever task it is getting, it divides in equal chunks and give it to the worker. Once the worker get all these tasks, worker will be working on this task. Once it is completed, it is returned back to the driver. Once all the information comes from each worker, it is going to take this task and give it back to the user. So I hope everything is clear for everyone. Databricks platform, this is a cluster. So we as discussed now, no? Cluster, now we have a runtime version. Runtime version is nothing but each version, software will have versions, right? Each cluster will have version. LTS is latest version. And the Spark, it will show like what Spark version is going to be installed
Sir,
into.
are you presenting something?
You can't see? 1 minute.
No.
You were seeing till now, right?
Yeah, but not now.
Okay. Okay, 1 minute. Now you can see, right?
Yes, yes.
Okay. Now we can see the, right. Okay. So this is the cluster which we, so similarly you will have, when it comes to paid version of Databricks, you will have an option here to add multiple computers. So rather than this one single compute, you will have maybe like I need 10 computes. You will be able to select the 10 computes here. So it will give you 10 virtual machine to run your process. So in case if you are processing huge data, then you will have sufficient capacity of computers to process your data and finish your work in faster manner. And you see notebooks here. I can go there because you will be able to see all the notebooks for which the cluster is running. Then you can see libraries means you will be able to install, like, normally we used to install PyPy libraries or something like that, right? You can just go and install this directly to your computer itself, so whenever you want you can import and use. Then there is something called a Spark UI, driver log, and all those things. This is one of the important stuff, but we'll come this to the at the end, because this is something which is known to optimize your program, reduce the number of like running time and all those things, which is a very important part of using Spark. So let's go, and so you can trigger a cluster both from here. You can either use this plus button to trigger the cluster, or else you can go here to your notebook, and from there you can start the cluster like this. Okay, now it's already starting, so I'm not getting an option to start. Okay, wait, it's disabled. Now the cluster have started. So because it's a community version, each time when your cluster goes down, then again you need to re-upload the data, because they don't provide all the services here. So I'm just trying to reload the data. Same yesterday's data. So once data is there, let me. So let's run this. So the first run, the cluster will need to initiate, it need to install its relevant stuff and all those things. It will take some time, but from second thing, once you, depending upon the stuff, it will start to run quickly. So we are just creating 4 data frames as Nikhil told yesterday, and creating temp views. Temp views are nothing but a kind of a table, but it is not physically stored anywhere. Once the cluster goes down, it will be automatically deleted. So basically, I'm creating 4 temporary tables which we will be able to access. I think this was done yesterday already. So let's go. This is also done yesterday. This is also done yesterday. Nikhil, till where Nikhil yesterday? Able to recall anyone? I think from here we will start today. Okay. So here the same query, Spark. We are running Spark itself. Spark, as we already told, like Spark is some. We are running on a Spark cluster, SQL functions. So let's see. Here our question is, for every admission, display the patient's full name, their admission diagnosis, and their doctor's full name who diagnosed the problem. So in that, so first of all, if you want, you can look at the. So you need a patients table. So let's see what is there in patients. So simply percentage SQL. So something which I wrote, percentage SQL. This is a magic command which is in Databricks. In case if this is a Python notebook, if you normally write something, you can only write a Python code. But in between, if you want to write a SQL code, you can use this magic command and then write SQL. Similarly, if you want to write a Scala, you can write Scala here and you can write Scala code. Okay. So let's select star from so you can now see all the data on patients. What is the question now? Question is asking you to display the full name. Full name means, in the sense, you need to have to join the first name and second name and their admission diagnosis. So for what they were diagnosed. So it's basically comes from, okay, so it has been joined on person ID to the admission. So from admission table it should come. So if you see in admissions, so admissions, and let's take for 1. So if in the case we'll just take for Laura, so we'll take the patient ID where patient ID equal to 1. So there is no admission details for 1. Let's try for, let's see what is there here, then we'll try something. So let's say 72. So here is the diagnostic. So now what the problem is, you need to join this to get this admission details. You need to join admission table or the admission view with the patient. Then only we will be able to find the reason of its diagnosis. So that's what we are going to do. Then the doctor full name, it should be available in the doctor. That again you need to join. Attending doctor ID is here, but you don't have name. So again we need to get those information from the doctor table. Let's see what is there in doctor table. is not found. Let's see what is the name. Doctors. Is it doctors? Doctors. Okay. So you have the doctor's name here. Now you need to join these three tables to get the information. So first from the patient, that is just the point of sale at the time of their registering, those information need to be joined to the admission table. From there we get diagnosis, and from there diagnosis you get doctor ID. This doctor ID need to be joined to the doctor table to get the doctor name. So that's what it has been done here. So it concats. So you need a full name. So first of all, let's concentrate in this join first. So first the patient table, which is named as A, is joining with admission table, which is named as B, on, because we have patient ID in both the tables, so we need to join on patient IDs. So patient ID A dot patient ID, that is patient dot patient ID, is equal to B dot patient ID, that is from the admission patient ID. So now in our once we join this, we have the information of diagnose, but we need doctor details also. Again, join with doctors, that is another temp view or a table now, or you can consider as a table, which is named as C. Now from B table you have attending doctor ID, which need to be equal to C. From doctors you should get doctor ID. So this, what happens is, here the doctor ID get compared with the doctor ID here in the diagonals, and from there you will be fetching the name here. 3 means it will be able to fetch the name Robert Bailey. So once it is done, what happens, then we need to concat. We have the first name and last name in the table here. We have first name and last name, no complete name. So you need the full name. So you need to concat. We need to use concat first name, last name as full name, then diagonalize, and then you get the information of the doctor also. So just first name, full name. So from C you get first name and full last name of doctor, that is the doctor's full name. So let's make it as patient for, and let's make it a doctor, just for a change. So once you run, you can use control enter or shift enter, will take you to the next one. Now you have patient name, diagnosis, and its full doctor name. So in case if you have any confusion about how to, like we have shared the notebook yesterday, I just just showing you something, just to, in case if you want, if I can export this notebook and give it to you as a DBC archive, you'll get some files like this, SQL coding practice DBC1. If you want to import this to your community version, nothing, you can go to file, click on import, just click on browse, you'll be able to see DBC file here. Just open this, you open here, so you'll be able to, so I have 2 files in the same name, so I just got the second file also here. So it's just straightforward. From there, just attach your cluster, start the cluster. Just start, I don't have option to start, just start the cluster and start running and using. You can run SQL, you can write Python code, any code. No need to write Spark code. If you want to write proper Python code, you can write it here. So that's it. Let's go to the next one. You can see my screen, right? Yeah. Okay. So let's see one more problem. So here show the patient ID, first name, last name from patients who have not any records in the admission table. There are patients does not exist in any admission. There are some patients which have taken the registration but never been gone to any doctor, that is the admission data is missing. So for that, what we is taking, we have a simple function which is called as note in. So you just get what all the information you need, patient ID, patient first name, last name from patient table, where this patient ID not in this complete table. Select patient ID from admission. So this select patient ID from admission gets all those patient ID in admission table. That means you have all the patient who have been met a doctor. And from here we get the patients and we run this command. So those patient ID which is not in this is what they are asking for. See, first name, last name for patients who does not have any records in the admission table. So that's also straightforward. Then we can look into another one. sort the province name in ascending order. In a way, the province Ontario is on the top. Select province name. You have province name in which you have in province names table or the temp view. Now you have to sort this in. You need to order this in ascending order. It's also like so you just need to give this. You need to just select the province name from the view and order by, where case statement when province name is equal to Ontario, we have something which is then 0, else 1, means whenever Ontario comes, it comes on the top. So here we don't have Ontario, it is been, so it is not. Let's change and see for California. California came in top. Let's try for Texas. So the Texas came on the top. Let's now try for Michigan. It's clear?